So when we're actually taking a analog voltage measurement and then we're converting it to a digital number, the two most common devices for doing that are your digital multimeter, your digital voltmeter, or your data acquisition system or your DAC board, right? So data acquisition systems often use digital to analog converters and analog to digital converters to interact with other instruments to read in data, and to control data they typically send out signals. So we're going to talk about what a digital analog converter and an analog to digital converter is in this video. So for a digital analog converter, which is shown on the right hand side here, how this works is the converter has these individual switches here, and those individual switches basically communicate to an op amp that's shown on the left hand side here, and basically depending on how uh, the the voltage divider is these individual voltage dividers are connected, it changes the value of this input voltage here, and basically this voltage difference here varies, and that affects our output voltage. Okay, so essentially, by controlling a set of switches in the center, we can vary the output voltage, right? And that output voltage is dependent on the the range of our signal. So depending if it's between uh, 0 to 10 and the number of bits. Okay, so typically we can so most digital analog converters typically go between are single-ended, meaning they can go between 0 volts to 10 volts above ground, or they can be binary, meaning they can go dual or bipolar, meaning they can go above 0 volts to up to 5 and below to -5. Okay, so typically the value of bits of most digital analog converters is between 8 and 18. So you would basically break up that range into that 0 to 10 volt range and divide that by 2 to the m to determine what's the smallest amount of resolution you would get in your digital to analog converter. Okay. Um, so for an analog to digital converter, um, uh, that's doing the opposite. It's taking an analog signal and converting it to a digital word. So the resolution of an analog to digital converter is dependent by the number of bits and the full scale range of the converter. Okay? So, for example, if we have a 2-bit analog to digital converter that's shown on the right, and it has shown on this figure here, and it has a range between 0 and 4 volts. Right. Um, uh, the its resolution would be equal to 4 volts over the voltage across the full scale range divided by 2 to the number of bits of 2. So we would have a range of 1 volt. So that's the sensitivity of that digital analog converter. Most digital analog converters have at least 8 bits. I would say most common now is probably 10, 12, 14, or even 16 bits. There are ones that can go up to 24, but those are typically used for only very small voltage measurements. And then for quantities, so we can, if we divide our Q value by a half, we can determine typically our quantization error. So typically we shift the most analog to digital converters shift by half of a value of our Q value. So typically between like 0 and 0.5 is what we consider to be is considered to be 0, and then and we basically just shift everything over by half of a amount. So basically, this allows us to quickly determine what is between 0 and what is between. I guess it allows us to decide what is our binary signal here. So for so In addition, some other properties of analog to digital converters include signal to noise ratio, which is just equivalent to 2 to the power of the number of bits that we have in our converter. This can also be rewritten in terms of decibels if we just take the log of that 2n value and multiply by 20, which is just the conversion from regular units to decibels. Saturation error is basically when you have an analog signal that is outside the range of your analog to digital converter. Right. So in this example here, our range was between 0 and 4 volts. So any signal that was above 4 volts would be considered a saturation error, because the analog to digital converter basically will tell you that it is still reading 4 volts, even though it might be reading 5 or 6 volts. And the same thing is if you had a negative signal, you could also be in the saturated range of your analog to digital converter. And then additional conversion error is going to be due to hysteresis, linearity, sensitivity, other errors that exist within the devices or the sensors plugged in. And then typically these conversion errors, they are specified on a technical data sheet. So sometimes this is referred to as like accuracy errors or other information there. Okay. So there are some errors that are associated with it, but typically analog to digital conversion is pretty good. Most of the devices that we use in class have pretty high analog to digital, have a pretty high number of bits. So when you're looking at different digital data acquisition systems, they typically tell you what the number of bits are and what the range is, and you can kind of estimate what's the smallest voltage that you could possibly measure using that analog to digital converter.